All right, algebra students, today is going to be the last section for chapter 2, and the previous section before this we talked about solving proportions, and now we're going to talk about solving proportions in geometry basically, or similar figures. So what I'd like for you to be able to do by the end of these notes is to solve for missing side lengths in figures that you know are similar to one another, and that can help you measure things indirectly. So first of all, what are two shapes that are considered to be similar to one another, or what qualities do they need to possess? So similar figures are when two shapes are proportionally so that's important, the same. And so that means kind of breaking that down even more, that's going to mean they have the same angle measures and side length ratios are equal as well. So it's the ratios that are equal, not the side lengths themselves. So here we have an example of two triangles that are considered to be similar to one another. So the 8 goes with the 12, and those are proportional. And then let me get another color here. The 10 goes with the 15. And finally, we have this 12 going with the 18. Okay, so when we have two shapes that are proportionally similar, we say that they are in fact similar. And a symbol for similar is one line with a little squiggle like this. So this line right here, that means, I'll put a little arrow, that means similar. Okay. So now that we have all that set up, how this is going to be broken down is we will compare corresponding sides to one another, just like we did with proportions, where we would compare two different values with one another. So let's look in example 1 and kind of put this into action. It's a multiple choice, and it says in the diagram, triangle ABC, so ABC, is similar to triangle DEF. What is DE? So what I'm trying to do is figure out the length of the segment from D to E. So I'm going to go ahead and color code that D and E corresponds with A and B. And then I'm going to find another side that I can compare that to. I'm going to choose BC and EF. The reason I'm doing that is because these are the two sides that I have information about for both of them. So that's why I need to use them, because then I'll be able to compare them. So now I'm going to do, you can do it a number of ways, kind of like what I was saying before, you just have to be consistent. So I'm going to say pink over green, and then pink over green. That's how I'll set that up. So I'll kind of show you that over to the side. So I'm doing 10 over green, or 10 over 16 is equal to, I don't know what this one is, but it's pink, so it's going to have to go on top. I'll just put an X in there for my variable, over green, which is 12. So remember, like I was talking about in our other proportion notes, just stay consistent and you will be fine. So I decided I'm doing pink over green, so that's what I did. I did pink over green, then pink over green. Okay, so now I'm going to cross multiply. I get 120 is equal to 16x. Divide by 16 on both sides, and x is going to equal 7.5. So over here in our options, that is option A. So I'm going to fill that in. And I'll go ahead and write it in on my triangle as well. Next it says use the figures of problem 1 to find AC. So now I'm trying to find this length right here. If we need to kind of mark it in another color, that's fine. So here's the blue. So now I have to decide what do I want to use this time. I'm going to do green over blue. That's how I'm going to do mine. So I have green over blue, or 16 over my unknown. So 16 over y is equal to green over blue again, 12 over 18. Once you set up your proportion, you've done the hard part of the problem. Now you're just ready to cross multiply and solve. So when we cross multiply, we get 12y is equal to 288. Divide by 12 on both sides, and we get, I'll write it over here, y is equal to 24. And that's my solution. So notice I'm just looking at the sides that correspond with one another, deciding how I want to set up my proportion, and then solving my proportion. It's simple as that. Okay, so in this next one, that bled. Whoopsies. In our next example, it says, a man who is 6 feet tall is standing next to a flagpole. The shadow of the man is 3.5 feet, and the shadow of the flagpole is 17.5 feet. What is the height of the flagpole? So first we need to figure out what are the two variables that we have going on here, or what are the two quantities, I should say, that we're comparing. We are comparing height, and we are comparing shadow length. So I'm going to go ahead and come over here to the edge, and I'm going to say right off the bat, I'm going to put height over shadow. That's how I know I'm going to set up my problem. Next, what is ideal is for you to go ahead and draw a picture. So let's say that we have the sun up here. He is shining bright. And here we have the man, and he's 6 feet tall. And it says that the shadow of the man is 3.5. So I'm going to label everything that I know. So I now know it's 6 feet and 3.5 feet. Then I also have a flagpole, so I'll draw that next to him. And it is 17.5 feet tall. And it also has a shadow. But this is what our unknown is. We don't know what that is, so I'll just label it F. We don't know how long the shadow is. So now I'm going to set up my proportion, and I'm going to use my picture as well as my kind of skeleton breakdown, so to speak, of the problem. I'm going to use both of these to guide me in setting up my proportion. So I decided I'm going to do height over shadow. So let's do the man first. Height over shadow, 6 over 3.5 is equal to, and then your next fraction, I'm doing height over shadow again. I have to make sure that stays matching. So for the flagpole, it's going to be 17.5 over my variable. I don't know what that is, so I'm going to say F. Now that you have your proportion all set up, you're able to solve like any other problem. So we're going to cross multiply. So we have it looks like I did this differently in my notes. So I was just wanting to double check. This is where I made a mistake. You guys, I made a mistake, so let me backtrack a little bit. This says the shadow of the flagpole. I am so sorry about that, you guys. So we need to flip-flop these two. Down here is the 17.5, and up here is the variable. I am so sorry about that. Error. So I accidentally labeled the height as 17.5, but right up here it says the shadow is 17.5. And I was looking at my work that I did beforehand. I'm like, this isn't matching. So what's up with that? But I'm happy I caught it when I did. So let's set up our proportion again. I apologize one more time. I did not mean to do that. So I'm going to have height over shadow, or 6 over 3.5, is equal to height, don't know it, so that's going to be F over and then shadow, which is 17.5. Now this is our correct proportion. Once again, the only thing I did, I just accidentally misread this or just lost that little detail. It said the shadow was 17.5, not the height. Okay, so now we're going to cross multiply. When we do that, we have 3.5F is equal to 105. Divide by 3.5 on both sides. And then we get F is equal to 30 feet. So that flagpole is going to be 30 feet tall. I'll go ahead and put that in there too. Alrighty. Moving on from that example. In example 3, it says the scale of a map is 1 centimeter to 15 kilometers. So 1 centimeter represents 15 kilometers. That's what that scale factor is telling us. And this is on the map itself. So then it says find the actual distance between two cities if the distance on a map measures 2.5 centimeters. So once again, I'm going to come over here to the side and I'm going to decide how do I want to set up my problem. I'm going to do map over real life. So map is going to be the centimeter. So I know 1 centimeter, it represents 15 kilometers in real life. So 1 over 15 is equal to, and then in my word problem, it says the distance on the map is 2.5. So the 2.5 needs to go on top of this fraction, and then I'm trying to figure out how many kilometers, so I'll just put a K in there for my variable. Okay, we're going to cross multiply. And when we do that, we get K is equal to 37.5 kilometers. Alrighty. We have one last example, and this is an example similar to what you might see in like a science museum or something like that. So it says a giant model heart is shown below. The heart is the ideal size for a person who is 170 feet tall. About what size would you expect the heart of a 6-foot man to be? So first of all, once again, we're considering and figuring out what are the two quantities that I'm comparing to form a ratio. So we are comparing height to the heart, or the height to the heart size, whatever. These are my two variables. So now I'm going to pull that information out of my word problem. So a giant model heart is shown below, don't have anything in there. It says the heart is the ideal size for a person who is 170 feet tall. So here we have a valuable piece of information, 170 feet. That is height. So I'm going to put that on top of this fraction. And then I also have how tall or how big this heart would be if it belonged to a 170-foot tall giant. It would be 14 feet tall or large or whatever. So I'm going to put this over 14. So once again, I did height over heart. Now I'm going to look at an average human being. So he is 6 foot tall. That's his height. So that needs to go in the top of my next fraction. I don't know the size of this heart, so they told me to put in X for that. Now I have my proportion and I'm ready to cross multiply and solve. So we have 170 times X, or 170X, is equal to, and then 14 times 6 is going to be 84. Now I want to get rid of this 170 in front of the x, so I'm going to get rid of that by dividing. And finally, x, which represents the height of the heart, is going to be about, I'm going to round it, so I'll actually turn that into a little wavy equal sign. It's going to be 0.49 feet. And I just put that in my calculator ahead of time, and that's why I know that. Alrighty, so that's everything you need to know when it comes to using proportions with scale factors. It's worked very, very similarly to other proportion word problems. You figure out what two quantities you're comparing, put them in consistent ratios, and then you solve the proportion. So if you have questions, be sure to bring them to me in class, but until then, have a good night.